are recording. All right. Welcome everyone to the Configure, Deploy, and Manage a Besu Private Network workshop for Wednesday, March 26, 2025. We would like to thank everyone for joining us, as well as the team from IO Builders for creating this workshop and doing such amazing work on the Besu certification. More to come on that later. Okay. This is a production of the Linux Foundation Decentralized Trust. We're the flagship organization for development and deployment of decentralized systems and technologies at the Linux Foundation. And our speakers are going to introduce themselves in a moment, but with all Linux Foundation meetings, this is held under the Linux Foundation antitrust policy. If you have any questions about these matters, please contact your company counsel, or if you're a member of the Linux Foundation, feel free to contact Andrew Updegrove of the firm Gesmer Updegrove LLP, which provides legal counsel to the Linux Foundation. This is also held on the Linux Foundation Code of Conduct. Links to both the antitrust and the Code of Conduct and everything else you're going to see today will be shared in a moment and a couple times an hour during the entire workshop. But the best way we can sum up our Code of Conduct is be excellent to each other, be kind to each other, and thank you for joining us in this event. And lastly, get involved. Sign up for a Linux Foundation account, check out our code, project code in GitHub, search for open bugs, report new ones in the bug database, look for good first tickets in the GitHub repo of a project you're interested in. Check out the contributor guidelines for projects and labs, find our meeting info, and use our communication channels if you have any questions. And once again, thank you very much. I would now like to stop sharing and turn this over to the IO Builders team with one last note. This is being recorded. It will be shared on YouTube. Because of the number of people who are going to be here and the great content that this team has put together, we can't do questions by voice. So we're going to ask everybody to put their questions into chat or Q&A, and we will try to answer them as you ask them, but also we'll try to answer them maybe at some breaks during the presentation. But thank you all. And I'll turn it over to the IO Builders team. Up to you.
Excellent. Thank you, Sean. So I will share my screen and we can start. Are you see my screen?
Looks good.
Perfect. So first of all, thank you everyone for joining us today. As Sean was saying, the idea of this, the title of this workshop says, we will be learning the main concepts and having some hands-on experience with Besu, particularly for private networks. Okay, so we are going to learn how things work in general, in particular with 4 exercises to deploy the network, add a new node to an already existing network. We will see a little bit of monitoring, and then finally we will see how to use Besu as a developer, to deploy a smart contract and then I invoke that smart contract, right? And in between of all that, we will also touch base on some theoretical knowledge or concepts for Besu and for Ethereum in general, right? And the goal of all of that is to give you guys a foundation of knowledge so that you can get started with the core topics that would be needed for for knowing obviously about Besu, but also for a certification that the Linux Foundation has put together for Besu, right? Just to share quickly, if you want to do the exercises, there are some prerequisites, right? Knowing a little bit of blockchain and Ethereum, but also having Docker and Docker Compose and MetaMask on your machine, so you can follow the steps. And then if you haven't done so, please download this repo, which has all the step-by-step of the exercises, right? So, and this is the content that I already mentioned. So, we are IO Builders, by the way. We have been working with Besu, since almost our inception as a company, mostly on the private networks area, right? An enterprise application for tokenization, etc. And our host today for you is our DevOps team, 2 of our DevOps team, right? And Marco Serradia, our lead architect, and myself, I am head of R&D, right? So Besu. Besu is an Ethereum client, right? It's an open source project, and it was initially, I mean, right now the project belongs to the Linux Foundation, right? So anything that you want to, Linux Foundation Decentralized Trust. So that means that any source of information or channels, etc., that you want to learn about Besu, you can go to the Linux Foundation Decentralized Trust documentation or website, right? By the way, you will see along all the presentation we have shared a lot of links for you to deep dive after this after the workshop if you are interested, right? The main content that you will see in this workshop today, you can find it in these 4 links here: the GitHub source code of Besu, the technical documentation, the wiki within the Linux Foundation Decentralized Trust, and within that wiki specifically the roadmap page, right? Which is, I mean, all of this plus our own experience and knowledge is what we have put together to the workshop, right? So as I was saying, Besu was initially created in 2018 under the name of Pantheon. Eventually, it was contributed to the Hyperlayer Foundation, which is now the Linux Foundation Decentralized Trust, in 2019. When the Hyperlayer Foundation became Linux Foundation Decentralized Trust, then the name of the project it was just it started to be just Besu instead of Hyperlayer Besu, right? That's why you will see in many places just Besu instead of Hyperlayer Besu normally, right? Then Besu as a Ethereum client, right? It is suitable for both public networks and private permission networks, right? In the case of public networks, you can deploy Besu as an execution client, right? In the case of private permission networks, there is no such concept of execution versus consensus client. So the one Besu node performs all the tasks of the Ethereum protocol as it was before the merge, right? So the Ethereum 1 client, to say so, right? In general, about the project, right? And the node itself, at the left, you have some metrics from late last year of the percentage of usage of Besu in the public Ethereum network, right? You have here the source, other nodes. Is at that point was maybe it's a little bit difficult to see, but it was 8% of all Besu of all nodes in the public network were Besu, right? On the other hand, on the private part, right, private permission networks, it is very recognized, right, as one of the main, let's say, technologies if you want to deploy a private Ethereum network, right? One of the several reports that exhibit this, right, is one of Blockdaemon that you can see in this little image, right? This is a survey of how many companies, how many projects were using these different protocols and clients, right, for private networks, right? And Besu there was a significantly higher amount of Besu of projects that were using Besu for private Ethereum for private networks in the context of tokenization. That was this particular survey, right? So the takeaway is that it is useful for both public and private networks, though for public networks it's not that relevant to say so at the moment. Is historically have been very used on the private and permission networks side, right? So, of course, it is an open source project, so you are more than invited to get involved, right? The starting point that we recommend is the Discord of the project, right? So you can get started and follow the path to become a maintainer, etc. Right? Then you have also, as with the majority of the Linux Foundation projects, you have you can go to the GitHub source code, the GitHub source code, and go for the good first issues, right? Which is normally a very common a way to get started with a project, right? And of course, you have more learning resources, as I shared before, the documentation. There are many tutorials and workshops already out there about Besu. So we just wanted to encourage you guys to deep dive on this. So a bit more about Besu. Besu has many different features, right, that you can categorize in these 5 buckets, right? First of all, as an Ethereum client, it implements all the features that you need for the Ethereum protocol, obviously, right? Both for public and private networks, right? And some examples of the features are, of course, the Ethereum JSON RPC API. In this case, Besu provides both, HTTP, WebSocket, pops up over WebSocket, right? The engine API for connected to a consensus client. All the main transactions types that the Ethereum protocol mandates are there. The peer-to-peer networking protocol, etc. Right? The storage. So everything that you need to have an Ethereum client, you have it, and obviously in Besu. Then for the private network features, you can find some additions, right, to the base Ethereum client to specifically to optimize the experience of using private network, right? For example, in the consensus algorithm of Besu, you can use proof of authority with QBFT, IBFT, ClickA, right? All of these are consensus agreements specifically for private networks. Then Besu have some native permissioning and access control features that we will see later, right? Like controlling which address can send transactions to a node, right? You have also some private transactions capabilities, which, to be honest, are deprecated right now, right? But like 6 months ago, you can set private transaction with Tessera, which we probably will cover later also in the workshop, right? And then there is some flexibility on turning the network parameters like the block size, the depth of the EVM stack, right? All this, the price of the gas or minimum price of the gas, right? All of these features are specifically designed for private network, right? Then it also provides some capabilities to manage the node and the full network, right? Some examples are the command line interface, the command line tool of Besu that can help you not only configure the node, but also perform some configuration tasks like creating the genesis, etc. Right? Then, as a JSON RPC APIs, you can also have some metrics of what happening with your node and with the network in general. Like you can inspect the transaction pool. You can inspect what the status of the QBFT or IBFT consensus algorithm. For example, you can check how many validators are there active right now. You can tweak and add or remove validators through the API, right? Which actually is something like that is what we're going to do later, and etc. Right? So other interfaces which are not Ethereum standard, to say so, but are there and very useful for monitoring and also private networks in general. And then there is some native capabilities of Besu for monitoring, like integration with Prometheus, right? Also, Besu is oriented to plugins, which means you can. There is an interface that you can easily deploy a plugin and connect to that interface and have access, for example, to new transaction that when new transaction are received, right? You can query what's happening with the, for example, the synchronization status, right? There is a list of plugin interfaces exposed to plugin that can help you customize and enrich your own Besu node, right? Then as the last bucket, right, we have the experimental features, which we also very quickly cover through. Some of the most interesting one are the parallel transaction processing feature that is still in early access, right? It's experimental. There's also an alternative elliptic curve which is the basically the R1, right? And several others that we will quickly cover, right? In terms of public networks, right? Besu, let's say if you want to use Besu for public or private network, the internal modules and architecture of the node itself and the way you will use it are 80% the same, but there are some different, right? First of all, in a public network, you will always, in the mainnet, right? You will always use Besu like this, and it's an execution client, right? This will be Besu, which exposes a JSON RPC API to a user, which can be an application or a user from using MetaMask, right? And through the engine API, it will communicate and exchange information with a consensus client, right? Like Teku, for example, right? And this and as it's part of the protocol, right? Right, for Ethereum after the merge, the execution client Besu will connect to other execution clients, right? In a peer-to-peer fashion. If you zoom a little bit on that execution client that we saw before, you will see the Besu core, right? Which is something like this. You can differentiate like four or five buckets of components, right? Of modules, which are first the networking, right? And the networking, of course, have to include all the basics of the Ethereum protocol, like discovery, and the ERR-LPX, the wire protocol, right? The storage is the Ethereum storage, the world state, etc., as defined in the yellow paper. And the execution engine is divided in the transaction pool and everything that has to be there to provide the transactions input to the Ethereum virtual machine. And then, of course, you have the interfaces to the user. There is another interface that is not described here, which is the peer-to-peer interface at some points, right, within the networking module, right? And also everything related to the engine API for the communication with the consensus client, right? And the pluggable execution, which is basically the some tricks that you can make to use the engine API, right? So that's the main thing about the public network, right? In the case of private networks, the way you will use Besu or deploy it, right, will be something like this. You will have your client, your Besu here, that take care of everything, both consensus and processing the transaction from Ethereum, from the users, etc. That same node will connect to other peer-to-peer to other nodes through a peer-to-peer communication, right? To conform the private or permission network. And if historically, although this is deprecated right now, if you enable the native privacy features, private transactions of Besu, you will get a connection with a third process or program, which is Tessera, which I don't want to get into detail right now, but the main takeaway is that Tessera handles the private payload of the transactions. The payload are not directly handle, let's say, the communication of that payload by Besu, but by this enclave, right? And if you are not using a private transaction, then you simply won't have Tessera. You just will have a private network without private transactions, just a network with your nodes connected, right? The internal, if you zoom in that private node, right, of Besu within the context of a private network, you will see something very similar to the architecture for the public network, right? The main thing that changes are the BFT networking subprotocol, because the BFT, so the consensus algorithm for private networks BFT, proof of authority, etc., needs another layer of message exchanges, right, between the nodes to reach the consensus, right? So it needs its own networking service, and also if you are using the Tessera for private transaction, you will have everything you need to communicate with the enclave, right? With the Tessera, which is some extra APIs and activated in Besu, etc. Right? And of course, everything related to all the modules related to the different consensus algorithm for private network that Besu provides. You can find it right from the perspective of a Besu network, right? And yeah, so that's the main thing right now. So how are we? 4:24. I think we can make some we can answer maybe some questions quickly before my colleague Guillermo runs you guys through the first exercise, which is deploying a private network, actually, right? So maybe
If you've got a question, please put it in chat or in the Q&A. I've fixed the chat so both the panelists and the attendees can leave a question in chat, but also Q&A is up and running and folks are using that as well.
Perfect. I'm seeing some question about ERC 4337. That's a great question, Latif. To be honest, I'm not aware of any support right now beyond what you have described. I might be wrong, right? Because the things are changing, like or have been changing with this new, with the Petra upgrade and the new ERC for the EOAs as smart contract during the period of a transaction, right? To be honest, I don't know right now at which point is Besu in the implementation of all of that. But the best way to get all the details is to ask in the Discord channel. Okay.
Awesome. Thank you, Alejandro. The person with the initials NR just asked, is Paladin seen as a viable replacement for Tessera?
Yes, definitely it is. In fact, the day it was announced that Tessera was going to be deprecated, there was already some signal that there was working for a replacement, and a few weeks later, Paladin was released. So, in my opinion, it is. In fact, some of the features that Paladin has are very similar to Tessera, particularly the Pente module, right, for handling private transactions. Having said that, I don't have a lot of visibility on the Paladin project right now. What is its roadmap in relation to Besu, etc. So my recommendation would be also to ask in the Paladin channel in Discord for more details.
Yeah, I'll try to find some Paladin links and I'll throw them in chat in a second. You did get a shout out from Alfonso. Congratulations, IO builders, for this workshop. Alfonso, you're awesome. Javier asked, is Hyperledger Besu suitable for handling high frequency data inputs, such as real-time tracking of, say, copper cathodes in a supply chain?
So high frequency data inputs, as far as I know, the highest amount of transactions per second that have been documented on Besu have been 400 transactions per second in a research a few years ago. And those transactions were basically ERC20s, a transfer in ERC20. So in general, maybe that's okay for your use case, Javier. But I don't know how much of the copper cathode, to be honest, how many data per second they send. But I will be cautious in general of when considering performance right now. But maybe that changes when the parallel transaction process is released and stable, right? But I will be cautious in anything that requires high frequency of transaction data, etc. Right? So
I'm going to ask one more question from the audience, and then I'm going to ask if one of the presenters who's not presenting could look at the Q&A and answer a couple more. Sudeep asked, how can I make sure which technology like Besu or Hedera suits my requirements? What are the main things we should consider before selecting, I guess, Besu?
So if you are, for example, if you want to go to, I'm assuming that if you're comparing Besu with Hedera, it's because you want to go to a public network. So I mean, it really depends on the use case that you have and the throughput that you need and the privacy requirements that you have. For example, Hedera being a public network, you cannot post certain details on your transactions, right? If you have strong confidentiality restrictions, you should go for a private network with Besu, right? So there are several factors that you will say. But to summarize, think always about privacy. Think about what level of interoperability you need with a community, right? A private network it could be a silo in some context, right? Because it's by default it's not connected to other networks. So yeah, privacy, interoperability, and maybe also performance, right? Hedera has a very elevated transaction per second ratio, right? Probably I mean more than a private Besu network, I would say, though that will have to be tested and compared. But yeah, those three, right? As by default. So I think Sean, we should continue right now.
Let's move forward. If for the attendees, if you've got a question, put it in chat or in Q&A. We'll try to answer them as we're going along, but I'd love it if the presenters could keep us moving. This is great. Thank you, Alejandro. That was awesome.
Thank you. So Guillermo, you want to go ahead?
Yeah. Hello, everyone. Thank you to be with us here today. And also thank you, Alex, for the overview. Let me share my screen. Okay, can you see my screen?
Yes.
Looking good.
Perfect. So let's start with the first exercise, that it's going to be deploy a private QBFT network. To do this exercise, we are going to follow the public EOP Besu Workshop repository that you have already in the chat, just in case that you want to follow the exercise, run it, or just deep dive. And the first exercise, basically what we are going to do is to deploy a local private Besu network. The consensus algorithm that we are going to use is proof of authority, that it's QBFT. And we basically are going to deploy 4 validator nodes: the validator 1, validator 2, validator 3, validator 4, an RPC node, and also an explorer that is going to be a web application to visualizations. The 4 validators are going to be the ones in charge to ensure the consensus, to run the consensus algorithm, and to validate new blocks. So the way that this proof of authority consensus works is that one validator proposes a new block, and the rest of the validators have to check if this block is correct, check all the transactions that are in the block, and if everything is right, the validators sync the new block and approve it. Okay, and to promote one new block, 2/3 of the validator nodes of the network have to approve that block. Okay, so that's are going to be the main functionality of the validators. Then we have the RPC node, that this node does not participate in the consensus. So it just bring an interface to communicate the network, the Besu network, with external interfaces like applications. If you want to make any transactions, or you want to get some information of the node, of the network, sorry, you have to go through this RPC node. And then, as I told you before, we are gonna deploy an explorer to just to check in our Chrome that the blocks are being mined, and all the validators are up and running and everything. So let's go to the code that we have it here. And the flow that we are going to follow to run this code is just to run this script, okay, the run.sh. These scripts, it just loads some environment variables here from the emp file, that is the Besu version that we are going to run, quorum version, the quorum explorer version, and other environment variables. Then we run a common SH script that you also have here in the repository. This script is just in charge to check that you have all the requirements and dependencies, and that your computer follow the characteristics to run this code, okay? And then the script just run a Docker Compose app, okay? So the Docker Compose that we have here. The Docker Compose, well, first of all, let me clarify that I'm gonna talk as these containers as if there were nodes, okay? So the Docker Compose is gonna be in charge to deploy all the 4 validators, all the RPC node, and also the block explorer. The code that is commented, it's for the following exercise, so don't watch it too much. So at the beginning of the Docker Compose, we have a template or a base that is going to be used by all the Besu nodes, okay, for validators and the RPC. And this template just use a hyperledger Besu as base image in the Besu version that we have defined it before in the environment file, that it's the 23.4.1. In case that we don't have this version defined, we just use the latest one. Then we load some other environment variables, but these are more for monitoring, so not needed now, really, are here in this file. And then we have an entry point. The entry point just execute the code in Bash. First of all, we copy our Genesis file to the path where we want the Genesis file to be inside the containers or the nodes in these cases, okay? And then we just run the main Besu command that runs the Besu code. And we pass to this command some parameters, okay? First of all, we have the config file where we indicate where to load all the Besu characteristics of how the nodes are going to be. Of course, all the parameters that you have inside this file, you can also put it here as more parameters, but I think that it's better to have it in another file to have just better visualization and everything. Then you have the peer-to-peer host parameter that sets the IP of the node. And then we have the RPC HTTP API and the RPC WebSocket API that here we just set what the allow interfaces are going to be in the nodes, okay? So here we got the list. Okay, so once we have the template, another important thing that all the containers or nodes are going to use is the network, okay? We have defined it at the end of the file, Docker network, that it's called EOP Besu network, and this network is the one that it's gonna allow the nodes, the Besu nodes, to communicate between them. Okay. So once we have these things, let's start with the services, the validator one. So the validator one parts as the template that we just seen, the Besu definition, and then we have just the name of the container. We open some needed ports, important, okay? We have the 9545 that is used for monitoring metrics, but we will see more this in the monitoring section. We have the 30303 that this is the port used by default by the Besu peers for the peer-to-peer protocol. Okay, this is the port which the validators are gonna use to communicate between each others. And then we have the 8545 linked to the 21001 in our local host. Okay, this is the port by default with the HTTP RPC API. Okay, then we have some environment variables that is more for monitoring, some labels, and then we mount some volumes in our container. Okay, so we mount our config Besu directory that we have in our storage is this one, the config Besu. Okay, all these files inside our config path in our container. Then we also mount our config nodes validator one. That this directory has all the keys of the validator one. Okay, it's this one, nodes validator one. We have here all the keys. I will tell you a bit more about the keys later. So we mount that keys in the path where the keys have to be inside the container, and then we mount another volume for logs that we will see later also. And then we specify that the validator one is going to be part of the EOP Besu network that we just specified before with this fixed IP. Okay. The validator one, it's also going to be the put node of the network. So the validator 2 basically is the same configuration. The only things that change is the exposed port in localhost linked to the port 8545 in the container. So we changed this. We also changed environment variables. We changed the keys. In this case, we checked the validator 2 keys that are also here, and we mounted in the in our path inside the container. And we also changed the fixed IP. Okay, we have here the 11, and here we have the 12. So same for the third one. We changed the linked port for 8545. We changed the environment variables, the keys, and the fixed IP. And the same for the fourth nodes. All of them are using the template that we defined at the beginning of the Docker Compose. Then we've got the RPC node. That as I just told you before, this is not going to be part of the consensus. This is going to be an interface between the network and the external applications. So the main difference here is also the IP, sorry, and the ports. Okay, we are going to expose the 8545 that it's the HTTP RPC API to the same port in localhost, so we can communicate through localhost in this port, and the same with the port 8546 that is the WebSocket one. Okay, it's the WebSocket RPC API. Then we have the Explorer. That this one doesn't use the Besu base or template. This use a image, the consensus quorum Explorer one that we have also specified the version in the M file at the beginning of the explanation. Then we mount some config volumes also that we also have here in the Quorum Explorer, the config and the m. Then this node depends on the RPC node because it's the interface that this node or this container used to get the information of the network. Okay, if the RPC node is not working, it doesn't make sense to have an explorer because we are not going to have any information. We expose the port inside the container, the 25000 to the 25000 in localhost. And of course, it's also part of the network and it has this IP. And that's it for the Docker Compose to deploy the network. So let's gonna go to let's dive deeper a bit in the config tome, that it's the configuration file that we pass to the Besu nodes. Okay, that it's this one that we got here. And what's inside this file? First of all, we specify the path of the Genesis file. Okay, so the Genesis file, the place where the Genesis file is going to be inside our containers. Okay, the same for the private key. So we mounted the keys here. So the private key is this one. Then the login that it's the log level that the containers or the nodes are going to run, in this case info, but if you need to do the book or whatever, you can set it here. The data path of the nodes, OPT Besu data. This basically is where all the data of the Besu nodes are going to be stored, and are basically the blocks. Okay, all the blocks data are going to be stored in this path. Then the host allow list, that it's just for everyone, allow any nodes to access nodes via API. And the mean gas price, that it's set to 0. Why is this? Because the gas is the cost for transactions, and in this case we are in a private network, so the transactions doesn't have any cost, so the mean gas price is set to 0. Then we have the RPC, WebSocket, GraphQL, and metrics configuration. We enable all of them, okay, and we listen all the IPs in the port 8545 for the HTTP RPC. Then for WebSockets, we allow all the IPs on the port 8546. Of course, to consume these endpoints, you have to be in the same network. So if you are not in the IOP Besu network that we specified before, you just can't go to these endpoints. Then the GraphQL, same, we enable for an IP port 8547. The GraphQL, it's for custom requests and maybe sometimes for some monitoring tools also. Then we allow the matrix in the port 9545, sorry, for every IPs. And then we pass through permissions. Okay, as we are on a private network, we enable the permission by a config file, and the config file with the permissions is here. Okay, that we have inside the config file. We will take a look later at the end of this file, but it's this one, and basically define the nodes that are allowed in the network. Then we have the boot node that, as I said before, is going to be the validator one, and this is the address of the node of the validator one, that it's just the public IP. Okay, this is the public IP, and then we've got the private IP of the node, that it's the one that ends with 11, that it's the validator one, and then the port, that is the peer-to-peer protocol port inside the network, that is the 3033. But more important to deploy a network from scratch is the static nodes file, because at the beginning, when there's no app nodes and we want to boot the network, the boot is set to a list of static files. Okay, so all the nodes that we are gonna boot are gonna sync and know each other's by this file, the static nodes JSON. Okay, so the permission config tone that it's here, we basically have the address of all the nodes that we are gonna deploy in the network. This is the RPC node, and then we have the validator 4, validator 3, validator 2, and the validator 1. And the static nodes, that it's the info that all the nodes have for sync between each other's at boot is the same, are the same addresses. Okay, so that's it for the config tone, and let's also check the Genesis file. Okay, the Genesis that we got in our config is this, and that then we copy to the specific path inside our containers. So what is the Genesis file? The Genesis file is the one that specifies the characteristics of the first block in the chain or in the blockchain, and it's gonna show the rest of the blocks how that chain is gonna be. So all the rest of the blocks are gonna follow the parameters of this one. Okay, so this is an important thing. So let's deep a bit more inside the Genesis file. The config. Okay, we have a chain ID that is just a chain identifier. This is important because when you join a network, or you have a node that you want to join a network, you need to know what chain is joining. Just because if you manage a lot of private networks, maybe you have a lot of chains and you just don't know to what chain you are joining or to what network, sorry, you are joining your node. Then we have here some configurations that with this 0, we just indicate from which block all these configurations are enabled. Okay, so all these configurations are enabled from block 0, the block Genesis, so just from the very beginning. Okay, then we have the 0 base fee to true. This is because, as we said before, this is a private network, so the transactions doesn't have cost, so the transaction fee is going to be 0. Then here we specify the consensus algorithm that, as we also said before, is going to be the QBF that is quorum Byzantine fault tolerance, and here you can put also some parameters. Here is the time in seconds that a new block is going to be mined or added to the chain, and the timeout that it's if anything goes wrong with a new propose of a new block in 10 seconds is the timeout to discard it. Okay, then we have some more things. The nonce, that it's a parameter to ensure that the hash of the block is unique. The timestamp, that is just the timestamp. The gas limit of the block, this is a high value, and for sure that we are not going to reach this value because our transaction gas is 0, so no problem with that. Then we have the difficulty that it's set to the minimum difficulty. This is because it's a private network and we don't want to spend any work in the mining of the blocks. Okay. Then the number of the blocks. This don't forget that this is the configuration of the Genesis block. So this is the block number 0. The gas used to mine it, that it's also 0. The parent hash. This block doesn't have parent, so the hash is 0. This is another hashes needed to mine the Genesis block. Some extra data. This is the address where the fee of the mining is gonna go, but here is no fee or is no reward, so this is not an address, and it's the Genesis file. And here we have the alloc sections, that these sections basically specify initial amounts for some wallets. No, this means that when this network starts or deploy, there's some accounts that are gonna be an initial balance. Okay, so this is just the address. The private key that is in a production network wouldn't be. Okay, the balance and everything for a lot of addresses. And then here at the end we have some addresses that we can find the worth code. Okay, this means that these are smart contracts basically. And this is for the Genesis file. So yeah, also let me tell you that you can generate the Genesis file or all the keys of the nodes using the consensus quorum repo, that I guess that it use this framework, and it just create all the keys. Okay, as you can so here, and you can also create the Genesis file. I let it in the chat also. And let's go to run the code. Okay, so to run the code, as I said before, we just have to run the run sh script, and there we have up and running the validator 1, the 2, the 3, the 4th, the RPC node, and the Explorer. Here we can also see the endpoints that we can use for the RPC node, the WebSocket one and the HTTP one, and also the Explorer. But first of all, let's check that the containers are up and running correctly. So Docker PS. Okay, so here also we can check that we have the Explorer running with the consensus quorum explorer, the hyperledger Besu. This one is validator 3, validator 4, validator 2, the RPC node, and the validator 1. So let's see some logs of this these containers. For example, the validator G. This one. Okay, so what can we see inside the logs? First of all, the best version that we are running. Okay. Then, well, we have a custom Genesis, the network ID that we have also specified in the Genesis file. If you remember, the 1337, the RCP HTTP interface is allowed with, and these kind of things. Then we have at the start charts and trying to connect to 5 static nodes that are the one that we have in the static nodes file config. And here we can see that we are enable the different services, the JSON RPC HTTP in this port. We also have the GraphQL. We've got the WebSocket RPC. We have more things that we can check. We can check here the e-node of our address, the e-node of our validator, in this case the validator 2, that's the public IP and the IP. And then here, maybe it doesn't sense very well. Here, the validator, it has synchronizes with the other validators and is importing and producing new blocks. Okay, so imported the block number 2, imported the block number 3, produces the block number 4, same imported for the number 5. And as we can see, we are not using gas, as we said. The gas is 0, and the transactions are also 0 because we just don't have transactions. Okay. And not much more here. Also, you can see the data storage, where it's going to be storage, and well, the discovery process and everything. Let's check for the RPC node also. The RPC node, this one. Okay, and it's mainly the same. Okay, same version, same network ID, same protocols. The only thing that you are gonna note is that this node doesn't produce new blocks. Okay, you can see that there's just imported number 5, imported number 6, number 7, number 8. So that's the main difference that we can see in the logs. Okay. Maybe we can also go inside one of these containers. Docker exec. Let's go to a validator run. For example. Okay, so for example, let me show you the data directory. If we go to the data directory, we can find the database that is here, and all the blocks are gonna be stored in these files. Okay, and not much more over here. Let me also show you the Explorer that we have here, the endpoint that we have here, and what we can see here is, well, that the status is up and running. That's a good thing. We have already mined 60 blocks. Sorry, we have 4 peers. These are the validator peers. Here you can check the e-nodes of every validators, and you can see that that the Explorer, it's taking the information of the RPC node in the port 8545, that it's this IP, and not much more. You can go and experiment and see more things here over here, but my colleagues will deeper will show us more about the Block Explorer later. So I let them explain us a bit more. I think that's all. Yeah.
Perfect. So maybe
No, just remember that if you want to try this, to run this exercise, you have here in the Besu Workshop repository in GitLab, and you can also check the consensus quorum on GitHub that we used as base to make this exercise, and also the quorum genesis tool. And that's it.
And if you're looking for the Quorum Genesis tool, Guillermo just shared that in chat a couple minutes ago.
This one, you mean? Oh, yeah.
npm.js, yeah. So Guillermo's already shared that. I'm going to add that to the list of links that we're going to put into the YouTube video in case folks want to follow up. Guillermo, someone did ask a question about a Google Doc you were sharing earlier.
Even this one?
I'm not sure.
I
You know
don't
what?
have-
I will follow up after the workshop and get slides and stuff. That one, yes, that's what Annie just said. That was the I guess those the presentation slides.
Yeah, that's
We
the
are going to share the
yeah, yeah.
slides, Annie.
Yeah.
I promise you. Does anyone have any questions for our presenters before we move on to the next section?
Sorry?
I was asking, do any of our attendees have any questions? If you could put it in
Okay.
chat or you put it in Q&A.
Yeah, I'm looking for some question how to decide how many validators to run. Well, the minimum, I guess that it's 3, and you always have to have 2 third parts of the validator nodes agree to mine any block. So as much validators as you've got, a block is gonna be more validated, no? But maybe also it takes a bit more time, so it depends on the requirements of your network, I guess.
Umair asks, in production, what is the recommended size for the virtual machine, and how do you manage volumes in production?
Well, I guess that it's the same. You have to look what are your requirements, no, of the network, how many transactions and per second or minute are you gonna have in blocks, and I can't tell you a number. Not sure.
Sure.
A good practice about the production that we have found useful, and correct me, Guillermo, no, is to between the sender of the transaction and the Besu node itself, put some kind of a queue or something like that receive the transactions and make sure they are there until are processed by the Besu node. If you have high volumes of transactions, that way, if the Besu node cannot handle the high volume of transaction, at least you have like kind of a queue in the middle that can allow for later retry or etc. Right? That's something that comes to mind when talking about volumes in production.
Yeah, thank you, Les.
SC asks, and this is going to be the last question before we jump to back into the presentation, but I do want to thank Marco for answering so many questions in Q&A. You are awesome. Can we add a validator after 6 months?
Yeah, Marcos, do you have
yes, for me, no, the question? Okay. Attending a validator to QBFT is responsibility of the rest of validators. It's a vote between the nodes. They manage itself, and so you can at the day of remove any validator when you need. Only needs the votes of the rest of validators.
So the answer, SC, is yes, you can, but it requires the approval of the other validators. Now, if you're running like your own testnet or something, you can add a validator, but I hope that answers the question. I'm going to turn it back over to our presenters. Please continue, and if you have a question, please put it either in chat or Q&A. I'd like to thank our presenters who are answering as many questions as they can.
Perfect. So I'm going to share screen again. Give me just one moment. Continue with the slides. Okay, and you see my screen?
We did a second, and then if you try to share again.
Oh, okay. Give me 1 second. Sorry.
No problem.
No?
Looks good, Alejandro. It says 02 configuration.
Exactly. Perfect. Thank you, Sean. So this is the exercise that we also with Guillermo. Thank you, Guillermo, about that. Now the next section on the workshop is a little bit of theory about the working layer, right? And then in another exercise, we will put in practice a little bit and see, the networking and peer-to-peer communications in motion, right? So about the networking layer in Besu. Well, this slide and a few others are what try to cover are concepts about Ethereum networks in general, right? Not only for for Besu, right? So these ideas and knowledge that you are seeing here is not Besu specific, right? So there is one thing. So after the merge, right? The Ethereum protocol for the peer-to-peer communication changed, right? To separate the networks in the consensus layer, which is a peer-to-peer network of consensus nodes, and the execution layer, which is a peer-to-peer network of execution layers like Besu, right? As I was saying at the beginning, private networks use the original Ethereum architecture, monolithic architecture, where there is only one node, one peer-to-peer network that does everything in the network, right? Some kind of node, actually, right? This so that's a little bit of intro in terms of why we see this duality, right? When we talk about Besu, right? Because Besu supports these both worlds, right? So about talking about networking, one of the main or principal topics is identifying nodes, right? So the using network addresses. Every node in a network, either public or private, must have an identifier, right? Ethereum historically has had three kind of supported formats for identifying nodes. First one, like very early in the history of Ethereum, was the multi-ADDR format, which is something like this. So we're saying separating, as you are seeing, separated by slash. Then it came the eNode format, where, to be honest, in my experience, it has been very present in the private networks environment, right? Using Besu, the eNode seem something like this, right? You have it always starts with the it's an URL basically, a URI, right? It starts with the word node, then it follows the public key of a node, right? As we saw with Guillermo earlier, all those will always have their own set of public and private keys to identify and sign message to exchange data with our nodes, right? So this will be the public key of the node, and then separated by the @ you will have the IP and the port for the peer-to-peer communication, right? And then the third recommended nowadays format for identifying nodes is the Ethereum node records, because it's basically a data structure. It allows more rich exchange of information. Like if, for example, it includes a signature, right? It have its own semantics for identity scheme and updating the some identity attributes of the node. Well, don't want to get into the specifics, but it's way more sophisticated than the previous two methods. And as I was saying, is nowadays there is a recommended way of identifying nodes, right? And yeah, so that's a little bit. The reason I'm saying this is because is the key and first step to use or to understand a network, either private, public, etc., is to understand what format is being used in your node or other node to identify the network, right? Yeah, so a little bit more about the legacy networking protocol of Ethereum, I mean legacy for public networks, for private network is pretty much present, as I was saying, right? So the Ethereum 1 networking protocols can be divided in two stacks, right? So the low-level protocol and the application level protocol, which all run through one of the low-level protocols, which is ERLPX, right? The low-level protocols are the discovery, right, which runs on top of UDP. It basically allows the nodes to, the first time they connect to a network, to exchange some data with a boot node or another kind of node, to be able to learn which peers are on the network, right? So that's the mission of the discovery protocol. The other low-level protocol is the RLPX, which is in a sense a transfer protocol, right? That wraps data for exchange between the nodes. ERPX, so within ERPX messages, you will find like the actual transactions, so everything that the nodes share in their peer-to-peer communications to actually build the network, right? Then in the application level protocols, you will find several of them. The main one, the significantly more important one in relation to the others, is the Ethereum Wire Protocol, ETH. As you can see it, as you will find in the GitHub, READMEs, etc., is a core protocol for exchanging data, right? In Ethereum 1 networks. It literally exchanges everything in this kind of Ethereum 1 network: the blockchain, the block header, the transactions payloads, everything that the network and the nodes need to communicate. Then there are other protocols like the Snap one, which is kind of for queries, right, from retrieving some data from the nodes. The specific protocol for light Ethereum clients, right, which is actually very actively being developed, an area being very developed right now on the community. I would say that in general the light clients, right? And some other protocols that at some point were very promising or have been used, I'm very sure. But as I was saying, the main one is Ethereum Wire Protocol, the ETH, right? So what happens in an ETH network from the moment a node connects, right? And this process that we're seeing here is what actually happens in private networks, right? First of all is the discovery, which, as I was saying, the node uses the discovery protocol over UDP to create what is called a bond with a boot node. In a bond, they exchange some basic information and create a communication to where the boot node, which the boot node is the one that already is part of the network, right? The boot node shares eventually a list of peers that it knows, right? With that, when the discovery is completed, the discovery only happens the first time the node is connected to the network, right? If you turn off the node and turn it on again, if it already has recorded a list of peer-to-peer networks, a list of peers on the network, it doesn't necessarily will go through the discovery. It will just connect directly to the peers, right? So after the discovery is completed and the node has their list of peers, it will try to communicate with those nodes and try to create an ERLPX session. This session is to kind of opening the transfer protocol, the transfer session for exchanging the actual data of the network, the peer-to-peer data, transaction block, etc. First step is doing a handshake, right, where they define encryption, etc. And then when that handshake is completed, they just start exchanging data, and the new node will start synchronizing. Will start asking nodes to, hey, give me the latest block, latest transaction, etc. And once the node is, well, I already jumped to the third part of the process, which is the Ethereum wire protocol. So after the synchronization is completed, the node is in a position to start propagating blocks or start propagating new transactions, etc. Right? Yeah, and that's it, right? So about the Ethereum 2 networks, as I mentioned at the beginning, after the merge, this Ethereum 1 process that we just see here somehow was divided, right? At least from a functional perspective, in the sense that the Ethereum execution clients, the Besu, right, will only take care of exchanging transaction data, transaction propagation, and the consensus client will take care of block propagation and the proof of stake consensus, right? And they will communicate with the engine API, as we saw a few slides at the beginning of the workshop, right? There is also some other differences between the Ethereum 2, between the execution client and consensus client, is that not only they literally build two separate peer-to-peer networks, right? They also use different stacks of technology for those networks, right? So the execution clients like Besu use Discovery version 4 and RLPX, while consensus clients use Discovery version 5 and SSC, right? Yeah, and last point about networking I want to mention is about synchronization specifically, right? Synchronization is it's one of the main parts that you will see on your day-to-day of using Besu, both for public or private networks. There are 4 modes of configuring your node to synchronize data, right? Mainly the takeaway of the synchronization mode is that for public network you will use Snap, and for private network you should use full synchronization mode, right? Snap basically tries to retrieve in the data structure of Ethereum, right? It doesn't go like one by one iterating on the full the full data structure just sequentially like that. But it also tried to retrieve leaves of the full try in the best way it can to kind of save some computation, right, in the process of retrieving the tree, right? And I mean, very high level description, okay? Then there is another synchronization mode, which is checkpoint, which is essentially the same as Snap. The difference is that instead of starting from the Genesis block, right, and I'm synchronizing everything from the very Genesis, it starts from a specific block that you define on the configuration of your node or the Genesis file, actually, right? There is another type which is fast. This is just deprecated, so don't bother too much deep diving on that. And the last one, as I was saying, is full. Full literally, goes downloading everything, not only the data structure of the world state as you would do with Snap, right, which is that process that I was describing before, but it will download everything, the transaction receipts, and process literally every block and every transactions from the beginning of the history of the blockchain, from the Genesis, right? Snap is more recommended for public chains, giving its more efficient way of selecting what data to download and the way it downloads is in process it, right? Full is more suitable for private networks, under the assumption that private networks obviously don't have the amount of data that you will find in the mainnet, right? The mainnet that is order of magnitude of terabytes. Private networks normally are not that big, right? Yeah, so that's the main thing about synchronization modes. So before jumping into permissions, maybe we can try and spend like literally 2 minutes to answer some questions.
Absolutely. Torsten asked, in a private chain QBFT, is it possible to create a snapshot on the boot node and then do a snap sync?
I mean, that's a great question. I would say yes, possible. It should be possible. The thing is, normally I would say that private network should use the full synchronization mode, right? Because it should normally is adequate for a private network, given the volume that normally are in private networks compared with the public network. The snap synchronization mode is, as I was saying, is specifically designed to save time when synchronizing with a huge amount of blockchain data, like in the mainnet. I mean, I think you could do that. The best way is to try it. But in my experience, full synchronization is what you will normally find in private networks. I hope that answers.
Awesome. Thank you. Umair asked a little while ago, and then I'll get to one more question, then we'll turn it back over to the presenters. Umair asked, have you tried this repository with the Besu latest version? If yes, how did you manage allocation in Genesis?
Sorry, Sean. Where can I see the question?
You got to scroll up. It's at 507 in the chat, not the Q&A.
Oh, okay, in the chat. Okay.
Yeah, at 507. It's about 19 minutes ago.
507.
And it's from Umair, UK. Have you tried this repository?
Have you tried the repository with the Besu latest version? I don't understand which repository. I don't know if it's referring to the.
It was earlier in the presentation, so we may have lost the context that they were referring to.
Yeah, sorry about that. If you're referring to the quorum, probably if we're referring to the quorum Genesis tool that Guillermo was sharing. If that's the question, to be honest, I don't know what's the latest version supported by that tool. I don't think it's the last one or version of Besu. The one of the tutorial that you were doing, Guillermo, is 23 something,
24,
right?
Yeah, 24.3 or something like that. We haven't tried the latest version.
Yeah.
All right.
Sorry, Sean.
No worries. This is great. Marcos is asking that question. Does anyone else have a question they want to ask in chat before we move on? Torsten said thank you. His private chain is running since 5 years, so full sync takes a while. Yeah, it would. 5 years. That's a lot.
Of course.
That's awesome. All right, you know what? Let's move on to permissions. Thank you, IO Builders team. You're up.
Okay, I will continue, Alex, if you're able, please. Okay, we need to take in account that create a private network hasn't the same requirements than a public network. In our case, each time that we prepare and planify a new private network is normal than only if you run in Besu nodes could communicate between them with the same Genesis file. And to reach them, normally we introduce node permissioning between the private network nodes. That's it. During the initialization of the edge of each node, or in the smart contract deployed inside the Genesis, we introduce the nodes that are able to connect between them, with the goal of don't permit share private data or share to other networks the same data. That is normally part of a regular planification of that Okay, normally it is possible to prepare through a TOML file and be part of the initialization of the node, or through the JSON RPC node API in the case of should be necessary. By another part, if we also need to restrict the access from some private keys to interact with the network and don't permit any created private key access to them, also we can introduce account permissions. Also, it's very common that if we restrict nodes, also restrict accounts, because it's very easy to that only a few private keys interact with each node. Okay. In fact, the permission in a smart contract should be deprecated, or right now is deprecated, in fact. But the only way to maintain that is with through the RPC or any TOML file and Besu commands inside during the starting part of the node. Please, next. And right now is the second exercise. Some other question to hear? Perfect. Continue.
Thank you, Marcos. Okay, well, hello everyone. My name is Josué Sánchez, and I will show you how to add a new node to our private network and join it, expecting that everything works. Okay, well, let me share you what exactly we need. That's not this. Is this. Okay, just to be sure, as we have said, as you can follow us in our GitHub repository, you can see the exercise. The idea is that how my friend or my colleague Guillermo has said before, we have a private network that consists of 4 validator nodes and 1 RPC node that let us make the HTTP request what we need in order to interact with the internal private network. So let's gonna what have we do in order to start a new node. Okay, based on the same Docker file that's in exercise 1, we have the same definition that we see. This is just a template with an anchor. We have the validator 1, validator 2, 3, 4. Okay, and the RPC node. In that case, that we want is to deploy a new node, have we have said. We have here the definition of the validator 5 that will be in that case. But if we check it, it has some little specific differences. Okay, first of all, it's on a different port, obviously, because if not, this would be a problem. Even if you see here that we are creating some keys for this new node, it's not exactly the case, because that we want here is to make him to create his own keys. Okay, this is the unique node of the demo of the exercises that will not have a predefined, pre-created keys. Okay, now I will tell you why. Okay, let's gonna see the definition that we have for this new validator 5. Okay, if we check it, it's more or less the same that we have for the static nodes that we have, the other 4 validators, but there is one thing that changes everything. Okay, in that case is the TOML. As you can see, it's not the same common TOML that we have. And if we check it, why? We could see that the principal difference is this is the normal config TOML that we have for the initial 4 validators. And this is the one who we have for the new. The unique difference is basically that we are not passing it the node private key file. Okay, that's why, because if we don't set these key files, the node will auto create these keys when it starts and tries to join. Okay, it has some implications. Okay, usually for the static nodes, we try to pass the keys created before. That's why if you start a node with a predefined key, the node will get an inode that will not change over the time. Okay, that's not the case for our new validator 5 that we are going to mount, because if we let it auto create the keys, it has one problem and is that in case that this node gets any kind of problem, if it needs to get restarted for some case, that inode will change. And that's a little problem if we have, as in our case, a private internal network with a local permissioning configured. Okay, what is the local permission configure? Well, as my colleague explained just before, it's the capacity to restrict the access to specific nodes or every node that tries to join to the network. Okay, for this we need to do some things. First of all is to add the variables that we can see here. Okay, let's try to enable the permission node config files, and obviously we need to pass it and permission config that, as we can see here, is just a list of which are the nodes that we allow to interact with our private network. If you can see now, we just have the 1, the 11, 12, 13, 14, and 15 that are our 5 main nodes that we have. The 4 validators and the ERPC node. Here is where we have to add the new node that we're going to add if we want that the new node could interact with a private network. How could we done it? Well, first of all, we need to start the new node. We haven't commented the definition, we haven't commented the anchor, but we need to uncomment this that will be the network for our new container. Okay, the external true, just simply add it to the previously created network that we have in the Docker file. Okay, with this, that we have is a new node that will be just in the same network as our Besu private network, but will not be able to do anything. Well, let me a second. Okay, now we can see, like happens to Guillermo, we have here a list of endpoints that we could check. For our case, we want to check that Quorum Explorer. Why? Because here we could see that we have not registered, but the quorum is able to encounter that new validator, but whoa, that's not what I expected. Okay, sorry, this is not working as expected. So let me please clean in a second and start again. Okay, it's gonna check that nothing is here. Need. Okay, everything is succeeded. Nice. Let's gonna try again if this work expected. Okay, here's everything okay. Let's gonna open this again. Let's gonna check. No, for some reason is getting a nice historic about the before blocks. Well, in that case, the idea is that validator 5, it's not able to connect to any peer, so it's impossible that it's meaning blocks because it's not in the allow list that we have checked it. Our permissions list. Okay.
Sorry, just I'm not sure if you were sharing the web browser, but we just seen the Visual Studio.
Oh, okay, man. Thank you for the advice.
Yeah.
Now I suppose it's okay. Okay. Well, I have said, I was just trying to show you that the Quorum Explorer, it could have the different validators connected and mining, but the validator 5 don't have any peer because it's not in the allow list, but for some reason now it's getting an historic of the mining blocks that have been mining before on my testing. Okay, the idea as I have said you, is to add this new node permission in the allow list. How can we do it? Okay, if we check the same exercise that we have in the GitLab repo, the idea is to make a request to the API that perm add node to allow list. This request needs to be done from where you were. In this case, we are going to make it from local, but needs to be done against every node that we want to be in his allow list. Okay. Currently, we only have the 4 static nodes from the start. So, well, that's gonna try to do it. But as you can see, we need some data that it's the enode validator. This could be get from the starting log from the container. Okay. Sorry. Sorry, but it seems to be failing something. Okay, everything's working. For some reason it's not finding. Okay, well. For our lucky, we could get the inode from the Quorum Explorer. We have it here. And in order to be able to, we need to make the curl. If we check, first of all, we could make a request in order to see in our current nodes with which are the allow list that we can see that it's the same exactly as in our static nodes. Okay, we only have the first validator, the RPC, and the other 3 validators. Okay, but if we make the curl in order to allow list, in order to add to the allow list, the new service. Okay, it's a success. It's only on the first validator. And if we wait for a few seconds, we could see that the new validator would have a new peer will change to 4 to 5. And obviously that our new validator will have 1 peer and has to be starting syncing with the blocks that he's found on the network. Okay. That we could do is to add it to the other nodes for the RPC too. Okay. And well, from this part, while he's trying to get the connection, for here is nothing, anything else that to configure. So let's gonna see if it's with the peer connected. It takes a few seconds, but some minutes. Okay, here we have one of them. Here is okay too. Okay, the peer 5. We have all the 5 peers connected the blocks are exactly synced with the current status of the network. Okay. Then it's all of this. It's a simple, very basic. Just remember that this based on our private internal with the QBFT protocol, and that we are running this local permissioning that is essentially if you want to control which nodes are able to go in your private network. Okay, so what I will is close this exercise. So if you have any question, please write or ask. Sorry for the inconveniences.
Oh, no worries. We have a question from Dalibor. By your experience at IO Builders, what is the expected maximum users per node in a Besu node? Parentheses, correctly handling API requests in parentheses.
Well, if I don't remember very bad, for the build nodes, that are the static nodes that you set on the startup, I suppose that there is no limit on how many connections could have. But for others or secondary nodes that will join to the network, I don't remember exactly if there are 1550 connections, the limit or something like this. Maybe it could be changed, but currently I can't remember it. I don't know if it answers your question.
No, no worries. But I think Dalibor, that hopefully that helps. Does the permission, this is from Moro I. Does the permissioning API also work for accounts? The problem that I have to solve is how to allow or disallow individual accounts all over the network without having to maintain node level allow lists. I was planning to use on-chain allow list, but now the relevant contract is deprecated.
Well, yes, it's totally okay. As we are doing here with the nodes, you can make the same local permissioning with accounts that restricts the access to the transactions that could be done. So, as I know, there's no problem with it. I don't know if it's a question because you don't have the knowledge about it, or maybe you have tried, but it's not working as expected.
Okay. Thank you. Is there another question before we move on? Going once, going twice. All right, IO Builders, keep going.
Okay. Well, then we pass to the monitoring, if it's okay. For this is the third exercise, and we will see how to monitor our internal private network from Besu. As a basic standard from the industry, we have that Besu supports Prometheus. Obviously, we need to add the metrics enable endpoint in this case that exposes any endpoint where metrics can be scraped. We have a lot of metrics categories that for this exactly example, we don't have to use it all because we don't have enough data for it. But as you know, or for just for your information, you could check it all of this in a real private network. We could configure the metrics exposure enable for Prometheus in order to send directly all the recollected metrics directly to. It's also supports OpenTelemetry, but in this case, we are just using the Grafana stack with Loki, Grafana, Open Prometheus, and Promtail in order to record. Okay, for the logs configuration, you could configure the basic login level, or you could have an advanced configuration if you implement the standard log4j configuration that is able to use. Okay, then we have other tools and resources that could be used if you have another monitoring use case, but we will not go inside this example. So please let me show you the third exercise where we are going to deploy an analytics tool in order to check what kind of things we can monitor from the Besu network. Okay, for the first example, or well, first what we have to do is I have said you we have a stack deployed in this example. They are all key or here commented. These parts are one Prometheus is the principal responsible for scraping the metrics. It's with a version of 2.46. It has a simple configuration of Prometheus that we could check here, in order that we only have configured that all the scrapings that we need in order to get all the metrics for the 5 validators, okay, on the RPC node. Okay, we have all consuming for the default metrics path for the HTTP with an interval of 15 seconds. That is enough for our use case. Okay, then here we have the job that tries to make some reliable configurations in order to, well, for us is just to help at the visualization level if you have anything to check. Okay, then we have the visualization tool, que es Grafana, a standard. As you can see, well, this is just for the demonstration. You can see that there are things that not be configured in a production environment. Here are the volumes that Grafana needs that we have defined it here. Here's where we define the volumes, and here's where we mount that. Okay, let's gonna uncomment all of this now. We have Loki that's responsible for the login. We have Promptail that is who will scrape that logs or collect that logs in order to pass it to Loki. So let me uncomment this. Let's gonna see if it works.
And while you're doing that, we do have a question in chat. Can we see the Grafana dashboards for this?
Sure. Well, we have just one dashboard. It has some things that I will show you in a few minutes. So I expect that it have all the things that you maybe are expecting. Okay, let me check if this run again. Okay, then we have it now. Currently working. Okay, let's gonna update with the new services. Okay, here is starting our monitoring part. Let's gonna see if it's okay. Okay, seems to be okay. Let's go see the import for the Grafana. Okay, now we could you could see that we have a little more endpoints. For example, the Prometheus address in where we go now. The only interesting things is that we could check if the targets are being scraped. We can see that the RPC node and the 5 validators are now up. So is Prometheus is scraping all we need. Later we have the Grafana address. We could check it. And this is the dashboard that we have. It's a default dashboard for now, but we could see the chain height, the target chain height. If there is any node with blocks behind, now they are totally changed. The total difficulty, the block time, the time since the last block have been read. The peer count, as you can see, every of the nodes are currently permission. So they are all connected to others in order to make the peer. And the peer limit use, that is very low because we have a lot of nodes. Okay, let me put it with a less. And here, well, this is what you can see. The block time currently is working very well. There is no node with blocks behind. The CPU consumed that are suffering the nodes. Test will not be high enough. The garbage collector time, but it's been a low time since it has startup, and the memory used by the different services. Okay, so you could say maybe one of the validators are working more than others. This is a very basic dashboard, but for this example show us different things that we need to, or that we want to know. Okay. Later, the other thing that has been startup, it's the login. Okay, here we could see the logs, everything that we need or we want. For example, if we want to check which are the e-nodes that every node have, because when he has startup, here we have all the information, everything is collected from Promtail and is sent to Loki directly in order to be working okay. Okay, if we check for certain logs, well, we could check that everything is working. We could filter by node, and we could see that everything seems to be okay. The proposal validator. Okay, that's one thing that we are going to check later. Because now, currently, we have the exercise, previous exercise, we have added a new validator node, but as you can see, it's working. So, well, this is the less we have. Let me check if there is something that we are missing now. These logs that you're checking this are parsed because we have, as my colleague Guillermo have said before, we have a log config that is working. It's trying to make that it looks like we expect. Okay, that's the configuration, the advanced configuration that I have said before. You can make a log for Java or custom plugin option. If you need something more specific, we're just trying to do the info level, so we are not having configurations for any warn or debug, even for the error, because we know that it works. But just for your information, it's an option. You have everything that you need. And for our part, please be sure that you try to test it. You're sure that it works on your local. If you have any improvement or any feedback, we're very glad to hear you and to keep improve always. For my part, it seems to be okay. I think there's nothing more to say. So that's the exercise that we have been showing. And I think the storage part is for my college. So I don't know if you're ready or there are questions that our assistants want to ask.
Yeah, we don't have any questions in chat. If you do have a question, please put it in chat or the Q&A. Again, thank you to Marcos for jumping into the Q&A and answering so many. That's been great. We want to keep the workshop moving. Okay, we do have one from VS. Would we do any corrective actions when monitoring shows something wrong?
Can you repeat, please? Or
Would we do any corrective actions when monitoring shows something is wrong?
well, it depends on what is wrong and what is happening. But for our case, we are just trying to be passive in that way. We're just waiting that if every alarm or everything on the monitor is working as expected, and we try to react as fast as possible, because for that stack that we have mounted, we don't have more capacity for it. But
Right.
yeah, it could be done.
VS, I would say the answer is yes, because you are actively monitoring something. It's just a slightly vague question, a little hard to answer in this context.
Okay, sorry.
Yeah, no worries. Are there any other questions? But it was a great, thank you, VS, for asking. If there's no other questions, we're going to let the team keep going. All right, IO builders, keep going. This is great.
Okay.
Okay. Let's
So
moving on to the next. I can share my screen. Oh, okay, thanks so much. Perfect. Let's moving on to storage to explain what is the needed of a storage for a Besu node. In our case, a Besu node needs to store a huge amount of information in several cases. But we will start by the basics. What is really storing a Besu node inside the self-storage? And in that case, the regular information, the regular structure of that we are seeing normally with interact with a node. As usual, we can ask for blocks. Then Besu node stores blocks in its storage. How it is stored? As usual, you are seeing the same information that you receive when you ask to a node for a block is very near to the final information that the storage is located inside the file system. How? Encode all the data with RLP as other things as our transaction where we are sending to the node. How it is structured? When you think in a DLT, always think in blocks, one behind other to the head block, and by each block, by each entry, a set of information. That is exactly that the Besu node is storing in its file system. What more? By each block, we need to store also what are the transactions that form part of this block. If the block is empty, the body doesn't have any transaction on it, an empty list. If there are someone, the list of each one. Depending on the consensus protocol, there are another extra information as part of the block in the header. Depending on the consensus protocol, should form part of the hash of the block or not. Also, by each block, we have a world state tree. What is that? The EFM information and what is the header and the the world state tree is the EFM information. In that moment, what is the key value information that is in that moment the correct. And all those information are stored always making a hash and with the data as value, and all of it is key value, all of it. Okay, that is a little problem because you need to recover all that information and fill it, all those information, all that information. And if you need to forget something, like a snap node or a full node, you need to have good structures to permit to prune all data and reduce the file storage. What is the difference? Full node only have the last part of the head part of the block of the blocks, and forget the rest. Okay. Why it is done by that part? Because they don't need to have all data of the DLT. Normally, when someone asks them for something that they don't have, it's not have, ask for archive node for that information and responds the user. Okay, it's very common that the node that responds JSON RPC information or permits receive transactions that should be configured as full nodes. And an archive node store all. Don't forget anything. Always have full information and full state. Of course, in a normal network should collide of them. Okay, should stay both of them configured by some way. As I said, normally the node that responds and receives transactions from the final users of the final APIs are configured, could be configured as full nodes, but the minded one or validators one in QBFT must to be archive nodes always. Okay. As we know, the way that the key value pairs are stored in the LevelDB database are going to be changed. Is going to be changed from the new versions of Besu nodes, and also in the regular Ethereum nodes, not only in Besu. The legacy one was Forest. Forest was good to save key value by a specific way. By each block, we have the whole state, leave nodes, all information related with that. Has less performance than OneSide, and supports is bad to prune data, and don't permits to do it, and is better for archive nodes. We don't need to remove anything, and it is easier to do it. By another part, OneSide is much better for full nodes, permits to prune data easily and use less storage than Forest one. There are one previous question in the chat related with that. We can make backups from our nodes and prevent the need to full sync the whole state of the network. And it's a common issue, okay? And the RocksDB, we need to think about it. It's a LevelDB empowered. It's only a key-value database. RocksDB also is used by Kafka, for example, and it's maintained by Facebook. is very robust solution, and almost Go Ethereum with C++ and Besu, that I know, uses the same solution. Okay. Okay. How a transaction is, how it works, how the EVM change its state, since a transfer of balance, transferring balance to interact with a smart contract. When a transaction is received by a JSON RPC node, that node only look a few things, very few things. Review that the signature is correct, review that if we have permissioning to accounts, review that the permissioning is part of the smart contract of permissioning, or is able to access through the corresponding configuration, and introduce it in the text pool. Once it validated, that light validation is done and introduces in the text pool, the text pool is a fully synchronized it's a method, it's a way to synchronize information between nodes, in fact, until the transaction was placed on the transaction pool. Immediately the Besu nodes try to communicate it to the rest of the Besu nodes. In the case of a BFT, in some moment, one of the validators that is a proposer in this moment select different by order, select one by one the transactions and try to execute it one by one, and generates the result. Don't change. It's a EVM state almost to continue executing the rest of transaction, but don't persist it, and complete the block to be validated with the rest of the validators in that network. Share that block with the rest of the validators, and each validator makes the same than the proposer. If there are enough validators voting that is the same result than the proposer one, the proposer stores the validator, the proposed block as final, and emit to the rest of the network. Okay, more or less, that is the whole path from the beginning to the end. How the EVM change its state? When the proposal says, okay, I have enough votes, I set the votes in the header, and I commit to the rest of the network, then that block is final. Their self changes its EVM state with the result of each transaction, and share that block to the rest, and makes exactly the same. The rest of the nodes that validators that previously says yes, it is correct, makes the same than the validator, and the nodes that aren't validators receives the block, execute transactional by transaction in her own state, and change its state. In the case of proof of work, it's more or less the same. but only change the tree that we are. If I am in a different tree than the main one, in the time, during that time, I have a different EVM state. And when I say, okay, I can continue, but that part, prune all these three and synchronize with the other. And in the case of proof of stake, the executor node don't think anything. And the proof of the second, the layer, the top layer says that is the final block, store in change in the EVM, your state, and let's go. Okay. What is the transaction types that Besu node be able to manage? In the case of private networks, Frontier. Okay, you can use Frontier right now with Tessera. With the next set with Kaleido, I'm not pretty sure. I think all of it, but I'm not sure. With the proof of stake, all of them from AP 159, because if not, you can't use proof of stake in any moment. It's the regular way to pay gas in this moment. Also, the rest. Okay, if Bluff to store temporarily big amount of data without a list to prevent unauthorized access to some types of transactions, you know, by the same way that the rest. And as I said previously, a transaction pool is the core place to share between the nodes whole transactions that JSON RPC receives. But it should be configured by different ways, depending of, in some cases, of the protocol, and in other cases, depending of the type of network. Okay. By a private network, the normal way to configure a transaction pool is the sequential one. It's easier to manage. In fact, is with 1 second per block, what is the minimum with QBFT is enough. You don't need to parallelize in a lot of occasions, and it's consistent in the same, in the same order that you receive the transaction, it was mined. Okay. You can okay, and in the case of public layers, depending how it is configured, in fact, with proof of stake, you are saying what is the amount of money that you will able to pay to be mined a transaction in is literally in layer type, and depending on the amount of money that you will able to pay, the transaction will be mined earlier or not, because the miners, the stakers are trying to win money, and the best priced are selected first. There are mechanisms to prevent few valuated never mind, but they take a lot. By another way, you can configure also your transaction pool to prioritize your own transactions or not. It is very important because one of the big issues of those type of nodes is the throughput, the transactionality. In some occasions, you need to send a lot of transactions in very few amount of time. prioritizing your transactions over the rest, you can send to the node more transactions down by one, and when the rest of the network was a bit less busy, you can send yours and don't lose almost a lot. And you can also, that is a very common scenario in public networks, you can decide when a transaction that stay in the transaction pool during a long time, when it is over, when it don't make sense to stay on there. For example, 1 day, 8 hours. Reach that time, that transaction is removed directly to the transaction pool. It's very common situation. And solve when in some occasions you send a lot of transactions and leave the whole to be filled at the end when a specific transaction then rise the rest, and by some occasion that transaction never comes, and you can recover for that situation, for example. And of course you can make transaction replacement. It's very common also. I send a transaction, that transaction never mind, I need to be hurry and send another transaction with the same norms, with more fees, and be replaced in the transaction pool, and it will be mined earlier. Those rules are specified in the 5.39 very well, better than I will explain. Please review it if you need. Okay, until here, some question until before I start with the exercise.
Yes, if you have a question, please put it either in Q&A or the chat, and we'll try to get to it before we start the exercise. We do have a question. Maybe someone can help TK. Running the lab with exercise 2, I found validator 5 still in started status. Is this normal? If not, how to make it in running status? I don't know if we're going to be able to troubleshoot this live.
Do you run, apologies, do you run the data compose app -d? If you don't, the changed configuration never goes up.
Okay, TK,
Okay.
you just got a bit of an answer there. The person who asked the question is still here, so
Yeah.
maybe they can
It
check.
should.
Does anyone else have a question for Marcos before we jump into the next exercise? Checking.
Okay.
All right, rock and roll.
Move on.
Go
Move
right ahead,
on.
IO Builders team.
Move on. Okay. Okay. To the more excited part of, I think, of all of this is to prepare a little test moving tokens between people. And with this exercise, we will try to do it by a simple way. What we need to do that is a MetaMask configured in your browser and the Remix ID. That ID is an online smart contract development integrated environment that permit develop and test in the same place any smart contract that you think. Okay. For testing proposals, I love it. It's very quick. Don't need a lot of resources, and permits to use any Solidity version available, and is maintained by the same community than the rest of the tooling, the common tooling in the Ethereum community. Okay, just only to to have it in count, I have yet configured a remix, pardon, apologies, a MetaMask, okay, in my laptop, in my browser, and also I have my remix here. Following the guides on the exercise 3 is the need that we need to do. In fact, wait a second. Here I am. The things that we need to do is the included in RC20 folder inside the EODET Besu workshop. Okay. What we need at the beginning: a MetaMask, a browser, and started a private network in our laptop. In that case, I will use exactly the same that we are using during the rest of the exercise. Should be able to work directly with the exercise 1. Just start the network and you have it. The most excited part is to review how the Explorer works, how Loki is changed, how Grafana represents changes. In my case, I have the first exercise done also. I start the network again and resume. Apologies, and we will see. Okay, we will see that. Okay, please wait a second. Then the services will start again, and I am able to access to the Block Explorer. Wait a sec. Prometheus board. Also, pardon, Prometheus form, Grafana board, and to see the logs. Okay, I have it all done and all prepared. Okay, and in the Grafana part of the dashboard to search in the logs, I introduce a string match that is 1tx. Look at wait a second. Look I remove it. That is the normal view of how the nodes are logging, and we are mining or validated. We have validated 6 blocks, but any transaction is sent. That I put is just that text in order to see only the blocks with 0 transactions, and if I change it, I have block transaction, 1 transaction. Okay. And my another part, we will use a smart contract, very common in that case, an RC20. If we don't know what it is, an RC20 is a smart contract that represents balances of accounts and permits to introduce new tokens in the system, to transfer one to another, and burn. But in that case, I don't remember if I have it, the burn. Okay. And it's very simple. We don't have any restriction over any external transaction. We can do everything in any moment. The only requirement is to have a balance in the correct account, and let's go. Only to be a little review about RC20, we have 2 events a transfer that is reset every time that I mint, burn, or transfer tokens, and an approval that is a way to say, hey, Marcos permits to Alex move tokens in my name, and Alex can transfer or burn my tokens. Okay. The total supply, that is, and yet, apologies, that is the storage information that form parts of the token. In fact, total supply is the total amount of tokens in the system, in the ERC20, the balance of each one of the users in the token as your bank account, more or less. Your allowance, that is I said. I permit to Alex move 100 tokens and move on. And the information about the ERC20, the name, the symbol, and the decimals. A constructor, it's the information needed to deploy the smart contract in the network. And when we deploy that smart contract in our private network, we need to set that information, the transfer, that my amount, my tokens are subtracted, and if I send 100 tokens from myself to Alejandro, myself subtract 100, Alejandro increase 100, and emits the transfer event. Approve, as I said before, I to Alex 100. Okay, an approval. The transfer from, that is, Alejandro is able to transfer tokens that I allow it. He can do it because has enough amount of tokens to do it. Subtract one to me, another to and send another to Alex, for example. And mint and burn, then the only thing that do is increase total supply and increase tokens in my account, or burn, that subtract tokens from my account and subtract token from the total supply. Okay. Once we review how the ERC20 is, let's move on to prepare the exercise completely. Perfect. I will leave the whole steps out of the screen, and I will do it directly in the navigator. I will speak in all of them bit by bit. Perfect. Okay. The first thing to do is to prepare MetaMask to be used with our private network. Okay. First of all, we need to unlock MetaMask. Okay. I will do it. Wait a sec. I need to search my password and unlock it. Perfect. As you are seeing, I have a local host yet configured, but I will try to do exactly the same, only to show how to do it. Okay. In the repository, we are saying, okay, add a new network and set the name localhost 8545. Okay, here I am. What is the RPC? Localhost 8545. Perfect. Okay. Identify 1337. Remember, we put it in the Genesis file. We put it in the Genesis file. Okay. The same that we use in the Genesis file should be there. Okay. ADH in that case. And the block explorer is the new one that we create during the initialization process of the network. And yet, okay, one of all of this is the proper configuration that you need to do in each one of our environments and store it. That is exactly the same than, oh, wait a second, here I am, than this. Localhost, 1337, ATH, and localhost explorer nodes. It's exactly the same. Perfect. Okay, move on to the next step, import accounts. We need to import 3 accounts in that case. The 3 of them are in the Genesis file with balance in the network. That's the reason because I am inserting it in Remix. How to add a new account? It's very easy. Here in the selecting the account, IDD account or hardware wallet. And here, IDD a new account from Ethereum. Name, Kaka, anyway. Okay. Oh, wait a second. I did it wrong. Okay. I will repeat. Apologies. I went so fast. That's it. Import account. Apologies. And here is where we need to paste the private key directly. Okay. Directly paste the private key. And that is to when we import it directly convert the private key and a public key and the public key, and from the public key extract the account address and appears as it is here. For example, okay, the first one, the 3, 4 is exactly this. Okay, and that one is the second that is represented in the guide, and the third one is exactly the same that the last one. Okay, please check then if 17f, 6273, 6273, and in the end, FE3B, FE3B. Okay, exactly the same. Perfect. Okay, we will need to check. We need to set here localhost and the account, the E3B. Perfect. The MetaMask preparation is done. We don't need to do anything more by now. Perfect. The second one, preparing the Remix workspace. When you enter first time to Remix, it will say you, okay, do you like to prepare an example? Of course, do it. Okay, in my case, I have 2 workspaces. The default one, that is the one that Remix creates by default and leaves you to test things. And I prepare another one and has my own testing contracts. And I prepare another one with the Besu Workshop that I have here. Perfect. And in that workspace, at the beginning is empty. You need to create contracts folder, create a new folder, and so on, and create inside contracts a new file with the rc20.sol. And then copy and paste the rc20.sol that are in our repository, Git repository. Okay, perfect. I have it here. The next one important thing. We have here a Solidity version called 0.6.0. By default, Remix always set the compiler as the latest one. Normally, 20 right now 29 0.8.29 with the commit corresponding commit. Okay. To compile properly, it's better to set exactly the same compiler version than specified in Pragma Solidity. At least in the 0.6.3. Okay. In my case, I prefer to use directly that one, and so on. Okay, it's very easy and fast. If you run compile directly, the contract is able to be used in some case. Okay, if we don't have any private network up and running, we can directly use the Remix event to test it. But in our case, we have a Remix connection with localhost configured, and it's easier to change the Remix Cancun from the injected provider MetaMask. Okay, here we are connected directly with our network, but if you don't do this step first, it wouldn't works. Okay, in Remix we need to do a little thing here. In that place, we need to include all accounts that can access to the local host. In our case, as we introduce 3 new accounts, we have connected the 3 accounts. That's it. If we need another one, we will set it and update. Okay, and that's it. We don't need anything more. Perfect. Reached this point, we are able to deploy the RC20 smart contract on our local network. Okay. That we propose in the example is to use in name Besu Workshop. That should be another one representing the name of the token that we are using in that case, P, a symbol, and 2 decimals in decimals. It is important. If I set here 0, no decimals are represented. But I say if I set 2.0 in our token should be 200. Must be 200. Okay. If I set 4, 20 more. Okay. Perfect. Okay. If we do transact, that is the next step, should occur one thing. MetaMask is opened and say, okay, we will sign a new transaction with 0 ethers from Remix Ethereum org to be signed. And we did. And we need to do confirm. Okay. The transaction is signed and is sent to the DLT, your local network. And it is mined, validated in the local network with this hash and this block hash. As we have a block explorer, we will search for the block hash, for example. And we have here, and it's a bit tricky because I have it here, the contract deployed, recently deployed. That is the block, exactly the same. And look for that, state root, receipt root, transaction root. That is the information that we are saying before that we need to store inside the DLD, inside the each node, etc., etc., etc. Okay, and the transaction that we send, C8355. Wait a sec. Here I am. Okay, here I am. Perfect. We have it here. But look at this. Here we have common information from the node. The transaction is exposed, but not have the result of the transaction. In Remix, we have the result of the transaction. And if we search for one transaction in our logs, we have here one transaction. And the 9826 9826 is the one that we are seeing. The nodes are receiving the transaction goes to the throat text pool to all network, the validators receive it, proposal catch it, review that it is good, share with the rest of validator, the rest vote for it, that vote looks for, okay, appears to be good, and the proposal says, perfect, this block is able to be mined and shared with the rest of validators till the RPC node. Okay, perfect. We have right now a token is managing funds in our system. What is the balance by default of all of our addresses? By default should be 0 because we don't have any minded amount set to anyone. Okay, 0, 0, and that the last one, 0. Okay, perfect. The next step in the guideline, okay, is to make a mint to one of the accounts. Perfect. That the one that we are able to mint tokens is the 6, the one that started with 6. Wait a sec. F1. No, it is incorrect. Wait a sec. Oop. Wait a sec. Here I am. Perfect. Mind. Here I am. Perfect. The 6 and 1 million, I think, of tokens. How it has 2 decimals is 100. What thousand? Okay, 10,000. Transact. As before, MetaMask is asking, okay, you need to sing. I sing it. And the network mine the transaction and looks forward about that transaction. In that case, it's different. The coded input is that and the coded output is empty. In that case, we have an decoded input from and to an amount, and the logs with the decoded output is an event. Do you remember when we reviewed the smart contract that we have an event transfer? That's it, from to and value. Okay. And also we have in a block the transaction inside the network. We will see 393F. 393F is jet. 393F. Okay, exactly the same. And if we will search again, wait a sec, that it will be updated. If not, we will continue. Let's move on, and it will be appearing in some moment. Okay, let's move on to the next one. It should be appearing here in some moment. Perfect. If we review from balance as the last time, we will see that 2 of them will continue with 0. It is 0. It is 0. And the only one that I mind has the correct balance. Okay. Okay. We will change the account to the one that receives the funds. Okay. In MetaMask, we will change to the 6273. And here, the same. Takes 2. Exactly the same. Perfect. And now we are transfer funds from 62 to F17. Okay, we will see. Okay, by the same, looking for the transaction. Transaction is signed, sent to the DLT, and the DLT appears here. Appears this 6855. 6855. And the event right now is a transfer again, but from and to has different values, and then value from the value is out to the value is in, and I will transfer it. Perfect. If now look for balances again, we will see that then two accounts has the same balance, because we do to review that to see the same, and the other doesn't have any balance. For example, we will start for the one that doesn't have any balance. Oh, apologies. I committed a little mistake. I choose the the first one, the one that I don't expect. Okay, one don't have any balance, and as I show the 7, the 6.2 has 5,000, and the if 1.7 has 5,000. And it's not part of the routine, but I think we can do it in a few minutes because we are going very good of time. We can do a burn. A burn is exactly the same than mint, but exceeding tokens from the token. For example, if you agree, we will remove the middle of the tokens from the F17 because they are doing a cash out. Okay, and here I am. Wait. Okay. Okay. I will repeat again, at least. Wait a second. Only to be sure that I am doing fine. Perfect. And if 1.7, I am doing apologies. Burn. 8.1.7, I am doing a burn with the amount of 2,500. Okay. Transact. As usual, sign the transaction, and the transaction is all goes as usual. It's mined. Okay. And we can see in the block explorer. And if we ask for balances, and we will have one with 0, one with 5,000, and one with 2,005. Okay. Perfect. Questions?
If you've got a question, please put it in the chat or in the Q&A section. TK has been getting some troubleshooting on following along with the demo. That is great.
Oh.
Does anyone else have a question they'd like to ask our presenters before we move on to the next section?
Yeah, TK, that error seems like something with maybe the Docker, the preparation of the Docker daemon, the Docker container to the file system. It just cannot create the logs. It doesn't seem like something that has to do with the Besu client or configuration itself. Maybe something with your file system or similar. I mean, it's difficult to debug like this. Sorry, but as Guillermo and Josue were suggesting, if you do a clean start, maybe that should help.
Alfonso is asking in chat, are there other wallet options with easier setup processes? Other wallet options from MetaMask, I believe is where Alfonso is going with that.
Yeah, I mean, there are. I don't think they would be much easier than what was shown here today. you will have to somehow configure. If you want to follow this exercise, you will have to import a private key, etc. And I mean, there are some cumbersome steps we recognize, but kind of think of right now of a better option.
Yeah.
I mean,
Yeah.
you can always do the exercise. If you just want to try remix, etc. You can do it, without using MetaMask at all. You can just do it locally in your remix. Sorry, Marcos, keep me honest here.
No, it's I am agree with Axel in that thing.
Yeah, and quite frankly, MetaMask is a great option when you're trying to do a demo and express something that a lot of people can use.
That's it. There are
Willing to
other
put in the
wallets.
time, you could use another wallet. Go ahead. Sorry, Marcus, go.
Yeah. There are another wallets, and you can configure a lot of things of that. But for those proposals, it's more than enough. Just in case we are using in some occasions, for example, no, Haspack, no.
Marcos, we can see a chat application.
Oh, wait a second.
So you seem to be sharing your Slack or your Discord. I'm not sure.
Okay. I'm sharing the thing that I am not trying to share. Okay. Apologies.
No worries.
Okay.
Any other questions for the IO Builders team before we jump to the next part? I have no new questions in Q&A. Want to give folks a chance in chat. Okay, if you do have a question, please put it in chat, and we'll either try to answer it during the presentation, or we'll at the next stop we'll bring it up. But IO Builders team, back to you. Thank you.
Perfect. Thank you, Sean. Michael, do you have your hand raised? You want to?
No. Apologies. I was trying to leave to share.
No worries. I think I can share now. Probably. Yeah. Can you see my screen?
Yes, we can see exercise 3, deploy and interact.
Perfect. Oh, that's a typo. It should be exercise 4. Sorry about that. Once we have done this exercise, this is our last section in the workshop, right? Which is a little bit about other features, right? So we will cover very quickly some privacy features which are deprecated, right? And some other non-privacy related features like this one that we are seeing here, right? So in the non-privacy category, we want to highlight this. TLS in general, in Besu, right? Can be convenient to some infrastructures, just so you know that Besu does support configuring the JSON RPC API with TLS, so that any client that sends a transaction have to be authenticated by the Besu node itself, right? There are roughly two ways of configure the TLS in the RPC interface, which are using a password, login and password, and then using JSON JWT tokens, right? And this, I mean, in my experience, using this kind of configuration, I mean, in the concepts of a private network, can make sense, but I would say 80% of the cases that I have been involved in, the authentication is managed by an off-chain component completely, right? So a backend or something like that, because you normally do authentication authorization in for many things beyond connecting to or using the JSON RPC API, and if you need a way to doing that, right, which is coherent with a full application, normally that would be handled by an off-chain backend that has a complex business logic for doing that. Besu, what can do is just check that the login and password that it knows are correct, or that the JSON token has been pre-configured previously in the node, right? By the way, all of this is per node, right? Every node would have a different configuration. Cool. So having said that, there is also a deprecated TLS configuration, which is related to Tessera. I won't do that too much, but when Besu and Tessera exchange information to handle private transactions, that communication, which is basically Besu calling an API in Tessera, could also be configured for use TLS with JSON tokens, right? That's it. That's TLS in general in Besu. Another interesting feature for private networks is configuring zero gas networks or free gas networks. Because in private networks, normally there is no need for a tokenomics schema to incentivize operators of the network to behave properly, by paying them with gas fees, right? So if you don't have that, having fees could be just cumbersome for the usability and in general the design of applications. So Besu has this configuration option specifically for private networks, which is all the network simply nobody pay gas for anything. The gas does exist and it's being used and it's computed by the nodes, etc. And you can see in the receipt how much gas has been consumed by a transaction, but there is no payment there is no fee, right? For using that gas. Okay. Cool. So that's one thing. The other is, in general, as we mentioned at the beginning, there are many early access features in Besu. You can see the early access feature with if you run the command line of Besu and use this --x help, and it will print just a huge amount of different configuration options that are unstable or early access. Of course, do that with caution. Ideally not in production environment. And of that long list, we have highlighted this with we think are very interesting, right? Once they are stable. First one is TLS in peer-to-peer. So same thing that we described before, but instead of the JSON RPC API, the peer-to-peer TLS for the peer-to-peer API between nodes, right? That could be interesting, even in enterprise or private network environment, right? Because if there are two companies that have to connect through the internet or even through a VPN, right? These two nodes, even in that case, having a TLS could be useful, right, for the peer-to-peer communication. That one thing. That also the parallel transaction processing is very interesting and very promising, right? You can see a lot of that in the documentation too. There is also an alternative curve to the elliptic curve that the Ethereum protocol uses. If you see the Ethereum, the curve that the Ethereum protocol uses is basically this one, but with a K here instead of an R, right? This curve is supported, for example, by Android and many devices. Is very beyond blockchain technology. Is very widely used. So supporting that could for example, improve the user experience because it could allow users to not use a wallet. They could just use native cryptographic capabilities of their mobile phones, etc. Right? So it's an interesting also feature. DNS in eNodes is also promising. Right now, we saw a few slides before, in the eNode you cannot put you can only put IPs and ports. You cannot put a proper domain name, right? And these features would allow that. Reorg compatible privacy. Well, I wouldn't say too much, but if you want to use Tessera with privacy, etc., you normally until the last version of the native privacy capabilities, you couldn't use, for example, Clique, which is a consensus algorithm that is prone to have reorganization of the chain. You can only use QBFT or IBFT, which are instant finality, etc. Right? Yeah. So, and the list is quite long, to be honest. There are many things. So I invite you to run this --x help and see it by yourself. last bit is about the Tessera. Marco, if you want to step in.
Okay, perfect. Okay, take in count that Besu can be used also in public networks as in private networks. And as I said before, the private network needs little differences that public one. In the case of privacy, is one of the most interesting features inside the private network, because depending of the transactions, some of them must be used, but must be seen by all of the intervenants in the network, but some of them don't really need to see it, all of those information. Is private information of that entity, or because it is sharing with another and only 2 or 3 of them needs to be seen. Okay. What is Tessera? The ability include to permits to Besu have the ability to hide transactions between nodes. Okay. Where is able from until November 2024? It's very important to be a good relationship between the intervenants in the network, because when you send a private transaction with Tessera, you and the other intervenants in the same private transaction will run, only you and the others will run the same transaction than you. And that includes a very strained relationship, okay? And it's important to think that the proof of the consensus protocol needs to be, as Alex said, needs to be with instant finality. If one transaction sent to the DLT should be removed in any near future, privacy is not able to be included to be used. Okay. Next one. That's perfect. How a private transaction is done? Okay. Very easy. The same object to a public transaction have a very little differences. One of them is to include the public key of the node that emits the transaction, that receives the transaction, the private transaction. Needs a privacy group or a relationship of Tessera's IDs to identify the others nodes and form part of the privacy, and only participate only the Tessera nodes that form parts of the privacy transaction receive the transaction. The rest don't receive it. Okay. And only the ones that receives the Tesseras that receives the transactions share with the Besu that transaction, and Besu can execute it. That's the reason, because I said before, if one malicious transaction then breaks a Besu node, will break the own one and the others. Okay. To manage the privacy, Besu differentiate each space with different nonces. Public space have different nonces that each one of the privacy groups, or different sets of privacy IDs that form parts of privacy group. That is very important. Okay, and also a tricky thing, if a transaction fails in the public space and the nonce increase, in some versions of Besu, the nonce doesn't increase. And taking count, if you need to broke something, can broke it, because inefficient contracts can generate problems in the Besu nodes that executes it. Okay, next one, Alejandro, please. Perfect. Very interesting feature, the privacy group. What's a privacy group? A set of nodes with Tessera. That's it. Each Tessera stores its own transactions, not the others. And it is very important. Besu maintains the public space and each one private space by a different way. Okay. What are the rules between public space and private space? In the same privacy group, I can read and write as in the public space. If I am asking for a state of public space from private space, I can do it. If I am in a privacy group, I can ask for another privacy group. Normal. And the public contract can access to the private contracts, to the private contracts. Also usual. It is very important because when you prepare environment with all those set of rules, restrict a lot how the contract can interact within them. Okay. Of course, there are different implementations of privacy. One of them is the Enterprise Ethereum Alliance implementation that uses the Tessera IDs to identify each privacy group. That is a bit tricky because if you have several Tesseras, it's only a list of privacy, a list of IDs. And if you change one of them, it's distinct privacy ID. When you send a transaction, in the transaction, you need to set all of the Tessera IDs that needs to be retrieved the transaction. It works, of course, but it's a bit difficult to maintain. Besu goes a bit more far away and introduce the privacy group ID definition. That is the same than before. I need a list of private Tessera IDs, private force. Okay, I store it in some way, and when I say that is the privacy ID, I recover the list of privacy ID and and I will execute on Tessera. Exactly the same, but less configuration. That's it. Normally, that implementation should comes with a smart contract deployed in the Genesis file, and all the privacy groups are defined on that smart contract. And in the end, with Tessera, it's possible to share the same Besu client with different environments. Each one with a different JWT can access to the node and have its own privacy groups. Okay, and don't see the other one. It's very interesting feature. Okay, next one, Alejandro, please. And The last one is the privacy plugin in Besu. It's an evolution of Tessera. In fact, that we are doing is we send a transaction to the utility with privacy group ID or the list of privacy from that are the Tessera IDs. Okay. When I send a transaction, instead of go to Tessera, encrypt the transaction payload inside the public space and share with the rest of the intervenants in the network. When a partner that form part of that privacy group receives the public space, the public transaction can decrypt it and can execute it. This way, reduce the amount of nodes needed to share private data, because you don't need a Tessera and need open ports and TLS keys to be configured to have all the inside the Besu node. But in the end, you are ciphering information in the public space to be unciphered by the ones that can. If you are losing completely your chain because you have a corrupted space or something like that, as you have the keys by default, you can reread all payloads and goes on. It's another way to generate and manage privacy inside Besu with QBFT or IBFT. Okay, and that's our fork. Questions?
Awesome. Thank you, Marcos, and thank you, the team. We'd like to turn it over to everyone who's joined us for questions. If you've got a question for the team about Besu, about just anything in this discussion, we would love it if you could share in either the chat or in the Q&A. Alfonso just said, thank you, Alejandro, Guillermo, Marcos, and Yasua for a great presentation. Thank you, Sean, for making it possible. Oh, thanks, dude. We know more about Besu. Best regards to all. Thanks, Alfonso. Very kind of you to say. But does anyone have any questions for the team on any of the presentation today? Okay, so I'm going to do a little bit more talking while folks think about it if they have a question. I will say, if you could check in the chat, you'll see a couple of things. Number one, there's a link to the wiki page for this workshop. There's a link to the repo that the team put for Paladin. There's a link to the repo for the demo that this team put together. There is a contributor calls playlist on YouTube. There is a Besu Wiki, and the Besu GitHub are also up there. Another thing I'd like you to check out is there is a Besu Certified Professionals cert with Linux Foundation training. We have a 30% off coupon code through April 30th. The coupon code is in chat. You're more than welcome to use that, and there's a link to the cert there as well. Angelina said, thank you for the presentation. This was very informative. Thank you, Angelina. That's very kind. Javier said, thanks to all. Great job. I'm not going to try that because my Spanish is almost as bad as my English. Gran trabajo de entrega de información. Saludos. I apologize to a beautiful language for my terrible pronunciation. Juan Luis said, thank you very much for the presentation. And TK in the Q&A, he tried another directory to clone the whole lab and uncommented those mentioned. Thanks for your efforts. It's truly an awesome workshop and presentation. Merci beaucoup. Thank you, TK. That was a very kind thing to say as well. All right, everybody, a couple of bits of follow-up. Number one, I'm going to post this workshop to YouTube probably in the next hour once the video encodes. All the links shared here will be in the YouTube description as well as on the wiki page. The Linux Foundation Discord, Linux Foundation Decentralized Trust Discord is linked above, and I'll post it again right here. There is a Besu channel. You can find this team in our Discord, as well as everybody else who works on Besu. Besu is a massive, awesome community of folks doing a lot of work. We also have a workshop from maybe 6 months ago about the Besu plugin architecture. I will find that and add that to the wiki as well. I think I appreciate everyone saying this was so great. Thank you so much. Kudos to this team. I had nothing to do with this. This team did an amazing job in this presentation of the workshop. With that, I would like to thank the IO Builders team. So Marcos, Guillermo, Yasua, and Alejandro, y'all are great. And this was a fantastic 3.5 hours. Great discussion, great question and answer, and really a great presentation and demo. The links are going to be in the YouTube and on the wiki page. And with that, does the IO Builders team have anything they want to say before we go?
Just thank everyone to stay with us.
Yeah, thank you everyone for the patience. Hopefully we have shared valuable knowledge today. Just to invite you to contribute to the project, the Microsoft project. So very happy guys to catch up on Discord or anywhere else.
Yeah, thanks so much for the attention and for receiving us so good.
Thank you all. Have a great day, everybody. And you'll see a thank you note from me probably in the next couple of days, again, with all the links and stuff. We just do that as a normal part of our course. But thank you, IO Builders team, and thank you, Linux Foundation Decentralized Trust community, for joining us. Have a great day, everybody.
Have a great one.
Thank you.
Thank you. Bye.